Come on. Okay, this doesn't work either. Right, my name's Pete Finnigan. I specialise in Oracle security and researching internals and security of Oracle databases. This talks about the wrapping mechanism used to hide PLSQL source code. I've been interested in this for quite some time, and my interest was made even stronger when I found this book on the internet, which I bought in 2003, which will become apparent why in a minute. I wanted to investigate why the method chosen by Oracle to secure source code is weak in PLSQL. I also felt that it was intriguing that Oracle had made it easy in quotes, because it's not that easy really, to unwrap PLSQL, basically because they provide interfaces to the APIs used. I'll move on to the next slide. So, the agenda. We're just going to look at a simple procedure. We're going to look at how it gets wrapped, where it's stored, the tables and views used, and various events and dump commands and so on to get data out of the database to see the internals of this. We're going to look at why it's possible to read wrapped code, and this has been driven by history and a design choice by Oracle in the way that PLSQL has been implemented. We're also going to look at how it's possible to read wrap code. That's primarily because of the APIs that Oracle have shipped. We're going to look at 10G briefly, and also a slide on some ideas on how you might protect your PLSQL source code. So what's the problem with wrapped PLSQL? The first half of this talk is going to concentrate on 9i, but some of these issues are valid for both versions. The wrapping mechanism changed in 10G. I don't know if anyone's aware of that. Some of the reasons why is because if you use the wrapping mechanism to hide your intellectual property, your algorithms, the way you've written your code, stuff you don't want your competitors to steal, if somebody can unwrap it, then they can steal those algorithms and work out how you've done something. So this could be your own application source code. It can also be critical data that's held in the source code. Obviously, Oracle ship a lot of the built-in packages that are wrapped with their own wrapper as well. In 9i and lower, which we'll look at in a second, I've got a slide on this, the wrapping mechanism also revealed information in the wrap file, particularly the symbol table. Of course, if you can unwrap PLSQL, then finding SQL injection bugs is also a lot easier, because you can just use tools like grep and search on Windows to look for particular vulnerable strings, concatenations and so on. There are PLSQL unwrapping tools available if you know where to look and who to ask to get them. They've been available probably since about 2003, and I know of 5 different ones at the moment. So the PLSQL language. So you've got PLSQL source code, you've got a PLSQL compiler front end. That compiles the PLSQL into an intermediate language called Diana, distributed, I think, I can't remember the name of it. We'll come back to that in a minute. It's an intermediate language. That is then parsed by the back end of the compiler to generate machine code. In this case, it's called M code in PLSQL. So Diana is the key for 9i and lower. PLSQL is based on Ada, so a lot of the design choices were because of Ada. The Diana is a descriptive intermediate attributed notation for Ada. This is actually an abstract data type, which means that it stores values and provides operations on those values. As we just said, it's an intermediate form of the PLSQL programs. That's not just for compiler. In the Ada world, it was also used for pretty printers and source code editors, syntax highlighted editors and so on. It is primarily intended to communicate between the front end and the back end of a PLSQL compiler. An interesting point is that each defining Diana entity represents a PLSQL entity. That's not just a particular node, it may be a set of nodes. Diana is built in trees. That's a logical construct. If it's actually implemented in trees, then that's just a coincidence. It doesn't have to be implemented as a tree, for instance, in a C code construct. The abstract syntax tree, there are actually two trees that are generated in Diana. An abstract syntax tree, which is constructed prior to the semantic analysis. That's just basically the structure, and that should map almost directly to the Ada formal definition when it was based on Ada. I guess it primarily does almost the same thing with PLSQL. It then becomes an attributed tree, so that each node in the tree also has attributes. We'll look at the attributes shortly. This is the Diana structure. I don't think my zipper thing works. There's also another language that comes into play, interface description language. Sometimes it's called interface definition language. Diana is written down as IDL. It's basically the language that's used at interfaces. This can either be an external interface or an internal interface. In the case of the database, there are 4 tables that you can find in the sys schema: sys.idl char $, sys.idl sb4$, and the other 2 that are listed there. Those store information about PLSQL. They store the symbol table, they store the Diana, and they store the machine code. The method that they're written down, that's called IDL, hence they're called IDL tables. So that's just an interpretation of the Diana that's written down to disk in a table. Wrapped PLSQL, if you hadn't already guessed, is just Diana that's written down in a different form when it's written out to an operating system file. Because if you look at a wrapped file, it's not the same format as what's in the IDL dollar tables, although the same information is actually there. So as we've said, is wrapped PLSQL, therefore Diana, reversible? Yes, it is. This book that I just held up, quite interestingly, has got an appendix called Reconstructing the Source, page 165. I'll just read these out. One of the basic principles of Diana is that the structure of the original source program is to be retained in the Diana representation. That's because in Ada, the abstract syntax tree mapped almost directly to the Ada formal description. There are some slight differences. So therefore, there's a close correspondence between Ada's syntax and Diana's structural attributes. Because PLSQL is based on Ada and the core language features are probably almost the same, then I guess that's still valid for PLSQL. And it's this correspondence that permits the source code reconstruction. And from Oracle's own documentation, so Oracle now confirms that PLSQL is based on Ada. As a result, PLSQL uses a variant of Diana, a tree-structured language. It's defined using a meta notation called IDL. Diana is used internally by compilers and other tools. So at compile time, PLSQL is translated into M code, and both the Diana and M code are stored in the database. That's not strictly true because the Diana is only stored in the database for procedures and functions and some other small bits of PLSQL. For instance, package bodies are not, the Diana is not stored in the database. So just create a simple procedure, about as simple as you can get. It's got no parameters, it's got no local variables, and it's just got a null statement for the main block. So you just go in SQL+ and create this. We can then save it, and then we can use the wrap mechanism to convert that to a wrapped file. So the wrap program is quite simple. You just give it an iname parameter and an oname parameter, and what it does is write the wrapped output to aa.pls in this case. And that's actually wrapped PLSQL, which, as we've already guessed, is Diana. I've got an example of a complete file here. This one shows it a bit better because it's the complete file, which is a bit harder to show in a slide. I don't know what this ABCD bit is at the top. Things that pop out immediately is the 920. This is from a 9.2 database, so that's clearly the version. Another obvious thing is the symbol table, because the only symbol in the program is AB, the name of the procedure. And pay particular attention to this list of hexadecimal values. We're going to see them again in a minute. So just taking a slight detour as to why 9i and below wrapped PLSQL has weaknesses. I've just created a simple procedure here that has no body in it, but that's intentional. It's just for a demonstration to show why there's a weakness. So this procedure called encode might be used to encrypt credit cards. And in there we've got a variable called key, and we're giving it a value 0123 up to F. And that in a real procedure would be passed as the key to an encryption function, and you encrypt the credit cards with it. If we wrap that using the same mechanism that we've just seen in the previous slide, and then actually look at the wrapped file, you can read the symbol table and you can see the word key, you can see 16, we can see varchar 2, and we can see the value. It doesn't take a lot of reasoning to understand that that's a key used in an encryption. I've actually got some of this written down in the next slide. So you deduce the purpose of the procedure. In this case, it was easy to deduce because it's called encode. It had a parameter called credit card. You could find out the encryption algorithm used inside the procedure if it was an external encryption algorithm using the DBA dependencies view. For instance, if DBMS obfuscation toolkit had been used to do the encryption, then that would be, you'd be able to find that from the DBA dependencies view. And in this case, because we've got the key and DBMS obfuscation toolkit only provides DES and DES3, we could reasonably assume that we can decrypt the credit cards. So even wrapped PLSQL source code is not secure. And this example, even though it's got no body, was taken from a real system in the UK that's used to encrypt about 20,000 credit cards that I was able to decrypt in about 2 minutes. It's also possible to plant Trojans in wrapped files without actually unwrapping them. I showed this about 5 years ago in a paper that I wrote, exploiting and protecting Oracle, where I found a string, I think it was something like alter session set NLS language, and I changed it to alter user sys identified by something else. And if you change that in a key file that was likely to be rerun by the DBA, for instance, something that gets picked up by catalog.sql or catprop, then there's a chance that you can leave it there and the DBA will run it for you. Change the sys password and you can get in later. SQL injection is probably possible, or whether you can actually describe it as SQL injection is another thing by doing the same technique. Oh yeah, and I mentioned here another issue I had when I was writing a program probably about 3 years ago. I was using DBMS output, and if everyone has used that before, usually it throws an error if you try and output more than 1 million bytes. And because it's wrapped, I reasoned that I could work out the algorithm, and I had Oracle 7.2 that was never shipped wrapped, so I could see the algorithm. And I found the variable that was actually set in the 1 million byte limit, and I edited it in the wrapped file, and I was able to then carry on using it. So it's possible to actually change the functionality of a wrapped PLSQL procedure, even without unwrapping it. So just looking inside the database as to what happens. Again, we've got PLSQL source code at the top. If you just loaded that into the database, then it'll compile it, and it stores the diameter and the M code in those 4 IDL tables that we saw earlier. And it also puts the source code in sys.source$, which is also exposed by DBA source and all source. Going the wrap route, the wrap creates the wrapped file, which is, as we know now, is Diana. Then the Diana is loaded back into the compiler, presumably, in the Oracle kernel, and loaded into the database in the same fashion as the back end of the compiler would if you just loaded it as clean source code. So just looking at these, these tables. On the right-hand side, you've got the details of one of the IDL tables, IDL UB1$. The interesting part is the piece column, because that's where the actual data is stored. You can actually get the descriptions of these tables and how they're constructed from a file that's in the Oracle Home RDBMS admin directory, a file called sql.bsq that's run every time somebody